Hello. Alright. It's not my first attempt doing this. I had some recording problems. Never used Bandicam before, but hopefully it works this time. I'm here to pretty much explain Dr. Ozbay's 2D wind tunnel simulation project. I believe this project is given to you in fluid mechanics and possibly with aerodynamics as well. Don't know if that's the case every semester, but yeah, 2D wind tunnel should be pretty straightforward. Right here, I'm going to be doing the 20 frequency or 20 hertz frequency example. So all my numbers you'll see later on are going to be correlated to this example, not necessarily the other two. We're going to follow all these parameters. First things first, go ahead and open up your workbench, your ANSYS workbench. Once it's open, we're going to use the Fluid Flow Fluent. Click and hold it, drag it over to your project schematic section. Also, excuse me, my allergies have been going crazy, so I'm probably going to be sniffing a lot during this. But furthermore, let's continue. So now that we have this, we're going to use this and come back to it quite a few times during this. We're just going to work through each section in a way you can imagine. Click the geometry by left-clicking. On the right side, don't forget here, important step is to switch it from 3D analysis type to 2D. I forgot that my first time doing it, and I had to redo the whole project. So now that you have 2D selected, go back to geometry, right click this. We're going to hit new design modeler. It's going to take a second to load, or it might be quick depending on your computer. My computer is not the most powerful, so it's not the quickest. Now that we have this open, we're going to go ahead and just click the XY plane. Okay. Z-axis right here, bottom right, for the camera view. This gives us a nice kind of 2D platform to work off of. This project is in inches, so I'm going to go ahead and switch it to inches, just so we don't have to do like conversions that are unnecessary. So right there, inches, it's under units. Now that we have this going, we're going to hit sketching, and we're just going to start plotting out our 2D wind tunnel. So the inlet is supposed to be 20, let me zoom out a little bit more. The inlet is supposed to be 22 inches. So I found it's easiest to do it this way that I'm about to show you, but you could do it however you want. I'm just gonna make it into two halves instead of one line and do a midpoint. Just like that, two lines from the middle down, vertically down. And then we could go to dimensions here on the left side. We're already in general, which is the one we need. Click on the line, just drag it to the left, click it again. Do the same thing for both. Alright, and since it has to be 22 inches, let me see, yep. We're just going to do 11 for each half, right? Okay, let me zoom out a little bit more now. Alright, so that's the inlet section. Let's go back up here to draw, hit line, and we're just going to be using the line tool pretty much here. Hit this, let's not go near steep, we'll just go kind of that, and then we'll do that, do that. Okay, dimensions, general, click this, go down. This is gonna be 15. See if it looks good now. Not funky. Converging bit is gonna be 24. Oh yeah, that looks a lot better. And then the test section is going to be 12. And this last diverging bit is going to be the big long part, which is 42. Alright, much better. Cool. We'll go ahead and hit the vertical dimension here again. Click that line. Click the midpoint. Cool. This has to be 3 inches because the test section only is 6 inches tall. But now we have that set. This is what it's supposed to look like, the bottom half. Just careful not to make this too vertical how I did there, and that's kind of what messed it up. So, draw, line, we're going to start from here, go horizontal, copy the same thing on this side. You could use a mirroring tool across the x-axis, but I am just going to do it line by line, just because it's pretty simple design. Here we go. Let's go back to dimensions. And it's going to be all the same measurements on the top side. Each 13 is going to be 15 degree or inches. Oh, sorry, my notes turned off. There we go. And then we're going to do the next one. That is going to be our L14. That will be 24 inches. Then we're going to do this bit. There we go. H15, which is supposed to be 12 inches. Okay. And then lastly, but not least, is that piece. And that is also going to be 42 inches. All right. Looks pretty good. Let's go ahead and hit the dimension tool and do vertical again. We're going to click this, click the midpoint. I'll just put it right here. That's V17, and that's going to be 3 inches. Since the test section is 6 inches in total, we're just dividing it by 2. All right, cool. Now you could see what is dimensioned, which is this whole blue section. It's constrained properly. This part is not. That's because we still have to do the degrees, which it says right here, the diffuser. That's going to be 3 degrees, and then we're going to close it off. To do that, we're going to hit angle. We're going to click on that piece, and click on the piece adjacent to it, and see how we got a little circle here. You could just click right there. It doesn't matter exactly where. 180 degrees would be, completely straight. So for this, we're going to do 177, I believe. Yep, there we go. And then we're going to do the angle tool once again from here. Click this line. Now we got another little circle. And this is going to be 180 would be straight. So for this one, we're going to do 183 because of the 3-degree difference. Almost done. It's looking nice and beautiful. Now we just have to connect the line at the end where the outlet is going to be. So I took the line tool. I'm going to click right there. And I'm going to click there. And now it being dark blue is kind of the indicator that everything is dimensioned correctly. Nothing is kind of dimensionless. It's all constrained. So sorry about the stop there. My video recording just cut off. So where I was left off pretty much, we have this all dimensioned, right? We're going to go ahead and click concept. We're going to hit surface from sketches, I believe. Oh, there we go. Yep, here it is here. Now we got to click the sketch. We're going to hit under modeling if I didn't open this before. You're going to hit sketch 1. Hit apply. And there we go. So now it's all light blue or cyan. You're going to hit generate. Now we have our object. Here you could save if you want the project. I'll go ahead and just click save. Why not? I'll put it in my summer classes. Sure, we'll put it right there. That's fine. Sketch. 2D wind tunnel. I don't know if it's really necessary to save this part because we're going to be saving more later, but there we are. So it's all generated. We're pretty much done on this part. We're going to update it in our workbench before closing it, just in case. I believe you right click, yep, and then you hit update. Got a little check mark, it was already there, but we should be good now on this. So we're going to go ahead and close the sketch now that our workbench is updated. That'll probably take a second for my computer, and we're going to open up the mesh tool right here. Once we're in the mesh section, we are going to, over on the left side, right click this mesh box. We're going to hit insert, and we're going to hit method. Left click that. Now we have this screen that pops up in the bottom left. For the geometry section, we're going to hit this, our object, and we're going to hit apply. We're not going to use this method though. So you're going to want to change this method here to triangles. After that, we are going to hit generate in the top left. That should generate here. If I look at it. There we go. Okay, cool. Now from here, we are going to hit this little square up here that says edge, right there. And we're gonna hit Control, click for all the wall pieces, like this. We're gonna do the bottom as well. I think you could Control press a letter here for like a quick shortcut. I don't know how to do that, so I'm gonna just right click and then go down to created name section. Yeah, I think it's like Control N or something. We're gonna name this because this is gonna pop up again later when we're finishing up this project. So we're gonna do wind tunnel walls for this. That's it. Just hit OK. Cool. Now we're gonna do the inlet. Control click, because mine was split into two pieces, remember. You could have possibly had one piece here. I'm gonna right click now on this, go down to create a name section. We're gonna do the same thing, wind tunnel, and then this we'll call inlet. Lastly, on the right side, just gonna left click it, right click to open this, go down, and then here we go, wind tunnel. Oop, I can't spell. And then outlet. Cool. And that's good there as far as the naming. One other thing we should do as well is changing the element here on the left side. We should make this element size to 0.01. I think that will be good for better accuracy. You'll see here after generating, the triangles are going to be smaller. Here it is now. And we should be good on this section. Let me just double check. Yep, that looks good. Okay, so we're going to go ahead and click the workbench. Here we are, back here. You're going to right click mesh, and we're going to just hit update. There should be a little check mark, assuming it works. There we go. So now we're done with this section. This section will be used in our setup now. So we could close this, that we're finished with that. And then we're going to left click the setup, double left click. This still was going to take a second to close. The wind tunnel popped up correctly with the inlet and outlet. So now we're going to go ahead on the left here for models. We're going to click this little plus button. We got to turn our energy equation on and double click that. Check it off. And we also have to move on to the viscous part right here. Double click that. Now this K omega has to be switched to the K epsilon. Down here where it says enhanced wall treatment, we're going to click that, turn that on. That'll give us these options will pop up. Pressure gradient effects, thermal effects. Go ahead and turn that all on and hit OK. Give that a second to process. When that is on, we're going to go ahead and move on to boundary conditions, which is, where is that at again? Unlit boundary conditions. I know it's here. There it is. There we go. Okay, cool. So we got our inlet right here. We're going to double click our inlet. This is the one we named earlier. ANSYS already knows from us doing the naming section. We're going to go ahead and change this magnitude. Now this is my magnitude based on my frequency. You're going to have to do your own calculations if you don't have the 20 hertz. But for me, the magnitude should be 1.256 to 36364 about. So that should be about that. Nothing else has to be done on this screen. We're not going to touch the turbulence. We're going to leave that be. And then we're going to hit apply. We got to make sure it fully applies before we close the window. Otherwise it could mess up our simulation, which has happened to me before. But it should be applied now. So I'm going to go ahead and close that window. After that, we're just going to go farther down to the solution section here on the left side. and we are going to click initialization. Right here, this window pops up. We're going to keep everything as is. We just got to initialize it, so you're going to click initialize. That's perfectly fine. It's not been saved. Okay, cool. Just want to make sure it went through. Alright, from there, we're now going to do run calculation. Go ahead and double click that. This window will pop up. We're going to change the number of iterations. I'm just going to do 150. I heard 100 to 200 is ideal. Don't know if that's true, but it worked for me before. So 150 is what we're going to do. And then we're going to go ahead and hit calculate. Give that a second to do its calculations. This graph pops up, which is about correct how it's supposed to look. These errors are fine. I'm not too sure why these errors pop up. Your computer might not do it. I don't know if it's a computer problem or what. But yeah, scaled residuals looks fine. I don't think we have to include this image. But if you do, this is where it is. Here's our mesh. Scaled residuals is in the top right. Okay. After that, we're going to go ahead and we're going to go on down farther to the results section. And where is it? It's right here, graphics. We're going to go ahead and click contours, double left click, just like the other sections. And then we're going to highlight everything here. 1, 2, 3, and 4. Just so it's pretty much saying, hey, all the surfaces are included. From there, you have like all these pressures and velocities and whatever you need to analyze your contour, your different contours. For this project, you're going to do static pressure, as shown. You can name your contours too if you want, for like images, if you want to take screenshots. And then you're going to go ahead and hit save and display. So you see here, that's static pressure. We could do another one. We could do the next one, which I believe is dynamic pressure. That's this one. Take a screenshot. Right there is the name of your contour. You could change the name of that if you want. And then after that would be total pressure. There it is, total pressure. And then lastly would just be velocity, right here. Velocity, magnitude, it's already on, save and display. And that's what it looks like. All right. And then you could see here too the no slip boundary condition, indicated by that dark blue section. Thought that was pretty cool when I seen it. We're going to go ahead and just close that window now. So that's what you need for that part of the projects. From there, you've got to get the plots, which we're also going to do on the left side down here. It's this plot section right here under results. Click that plus. Here we have the XY. Double click that. Now we have this. It's opened up. So we're going to have to create a new surface. If you followed what I did for the sketching, this should be the easiest way to do it. You're going to hit new surface, line/rake. After this little window pops up, this one right here. You could name the surface center line, because this is where it takes place for the diagram. Center line, call it that. And then the distance from the inlet here, right here in the middle, all the way to the end. I did this earlier in the calculations, is 2.3259. That's the total distance of the wind tunnel. Now that you have that done, there's nothing else you have to do on this page. Just hit create. And see how it popped up there? We created a new surface called centerline. Okay. You're going to select the centerline surface. And then lastly, just like the other page for the contour page, here on the right side, we have our pressures and all that kind of stuff. You can hit this save/plot, and it will show you right here. So static pressure. That's our static pressure graph. That looks correct to me. Next is dynamic pressure. You just click that, save and plot. Lastly is the total pressure. That's it for the pressures. Right here, just like the other one, you could drop down, hit velocity. Velocity magnitude's already selected. Go and click it. There you go. That's your velocity throughout the middle of the wind tunnel. X position versus the velocity. Okay. And that should be it for the project. From start to finish, you should be pretty much good to go. Yeah, as shown here, all of the stuff is checked off. If you want to go ahead and get the files for your Excel, like the data, right here on the left side, it's just hit write to file, and then you can do it that way. Just write the file, and then you could save it wherever in your computer. Okay? I hope this tutorial did help you on getting this project done, because I know ANSYS at first could be a little overwhelming. So, yeah, hope you guys have a great day, and I'll talk to you later.